Welcome back. Now, things are looking pretty nice. We have our drone blasting at least one time with left and right rifles, but things aren't really sounding all that great. In fact, we don't have any sound at all. And typically when something like a drone fires a blaster beam, there's a sound associated with that. Well, we can do that in Unreal Engine, but to do that we have to have sound assets. Luckily, I'm providing you with sound assets in the asset files for this course. If you look in the drone folder, you'll see that there are some .wav files. .wav is the file type that Unreal Engine supports. They're much higher quality than MP3s, for example. And we have 3 drone energy rifle sounds. Now, whenever I pull up these folders and show the assets, you may have more in these folders than what I'm showing now, as I'm adding more while I create the course, but we want these 3 sound files in our project. And we want to keep our project nice and neat, so in our assets folder, we're going to create a new folder for sounds. So we'll call this sounds, go into that folder, right-click and make a new folder, and we're going to make sounds for the drone. So we're going to make a drone folder, and in here, we're going to get those WAV files in. So I can just drag these in from Explorer, all 3 selected at the same time. I could drag them in. I could also click import if I wanted to do it that way. I typically like to drag them in usually, so I'm going to drag them right here onto the content drawer. And now we have 3 Soundwave files. And if we hover over them, Unreal Engine gives us a nice, convenient way to just preview how they sound with the little play button. So if I click play on one of them, that's what it sounds like. I can do the same for the other 2. So we have these really cool sci-fi energy rifle sounds. Now we could play a sound using the WAV file all by itself if we wanted to. I'll show you that first because it's good to know about. But then we're going to use a more sophisticated type of asset than a sound wave. We're going to create a meta sound, and that allows us to customize our sound even more. But first, let's learn how to just play a sound. We're going to go to BP Bot. And I don't need my BP Blaster Beam for now. I'm going to close it. I don't need my Beam Burst Niagara system. I'll close that. And we're going to go into our spawn blaster beam function. Before we do that, I'm going to delete this call where we're passing in the right rifle. I only want to spawn at the left rifle for now. And let's go into spawn blaster beam. We'll open that up and we're going to go ahead and spawn a sound here. So I can right click and I can type play sound, and we have a couple of options. We have play sound 2D and play sound at location. Now the difference between these two is that play sound 2D will play the sound at the same volume no matter where the sound source is. In fact, there isn't really a defined location for playing a sound 2D, whereas play sound at location plays the sound at the given location, which means that if we're farther away from that location, it will not play as loud. And if we're far enough away, we might not hear it at all. That's more realistic, and that's what we're going to use. So I'm going to choose play sound at location. We're going to go ahead and hook it up, and we'll use the location from our get socket transform. So for now, I'm just going to take the return value location from get socket transform back here and drag it through. I know we don't like wires going behind nodes like this, but just for now, we're going to use that location, and I'm going to hard code in a value by selecting one from the dropdown, and I'll choose Energy Rifle 01, and we'll just see what that sounds like. So now our function is playing a sound at the location of the socket. Let's see what that sounds like. I'll press play. And there it goes. And that sounds great. Now I mentioned that play sound at location means that the farther we are from that location, the more quiet that sound will be. But if I press play and I go way back, it still plays at the same volume. So we're not getting a sound fall off. Well, we're going to learn in this video how to make that sound fall off work properly as well. Now, I mentioned that this is not the way we're going to handle things. We're not going to play a sound wave directly. I'd like to make a more sophisticated type of sound asset called a metasound. And we're going to see some of the strengths of the metasound asset as we create one. So let's learn how to create a metasound. I'd like to create this metasound asset right here in Assets, Sounds, Drone, along with our sound waves. Let's right-click and go to Audio, and under Audio, we have Metasound Source. That's what we'd like to create, so I'm going to create that. And I typically like to prefix my metasound assets with SFX for sound effects. And I'm going to call this SFX Energy Rifle. And we're going to go ahead and double-click SFX Energy Rifle to open our metasound. And metasounds are quite interesting. Audio engineers who specialize in audio for video games learn all about the inner workings of metasounds. In this video, we're going to create a basic metasound, but we'll add some fun features to it. Now, our metasound has its own graph, and it also has its own details panel, which will change depending on what we have selected, of course. In the members panel, we have a number of things. For one, we have an inputs category, an outputs category, and then we have variables. So as you can see, things can get quite complex. Now, let's first take a look at the outputs. Notice we have under UE, output format, mono, out mono. And we have a node in the graph called output, which has an input called out mono. Now, this is because sounds can be either stereo or mono. Mono just means there's a single audio channel. So our left and right speakers or headphones are going to play the same sound. Whereas stereo means that the left and right speakers or headphones are going to play different sounds, and it gives a bit of a more three-dimensional feel to the sounds. So we're going to see, or hear rather, the difference between mono and stereo with our Energy Rifle sound effect. Now, the first thing we have to do is learn how to associate our wave files with our metasound. So these three sound wave files need to be here in our metasound somehow. That's where the input comes in under members. If we go up to the input category and select on play here, we need to add an input. Metasounds require some kind of sound data. So to add an input, we use plus here. We click on plus input, and inputs can have their own data types. By default, it gives us an input called input with the type float. But we don't want a float, we want an input whose data type is a wave asset. So we're going to click the drop-down that says float, search for wave, and choose wave asset. That's the type of input we need. So now that we have wave asset, we're going to change its input. Even though input is a descriptive name for what it is, we're going to rename it just to understand that our input has this particular name here. We're going to call this rifle input. And it looks like I severely misspelled rifle. Let's do that right. R-I-F-L-E. And now that we've renamed it here, we can see that it's renamed up here. It says rifle input. Now, this rifle input can be dragged out onto the graph here, and we have a node for it. And we can drag off of its output pin and get the value for this input. But it doesn't have any value assigned to it because it needs a default value. So under the details panel for rifle input, we can select a default value. And as we see, we can choose from any number of sound wave files. So let's just choose one of them. We'll choose the first one. And we need to use this value to play a sound. You may have noticed that there's a play button up here at the top. But it has warnings if we click on play. Well, nothing happens because we need to do something here in the graph to specify what happens when we press play. Now, the way to play this wave asset is to right-click in the graph and search for a specific kind of node called a wave player. And notice we have several options. Let's just start with the first one, Wave Player 1.0 Mono. Here's what it looks like. Now, there's a whole lot of things here, so let's just talk about the very basics that we need to understand. When this meta sound plays, our input node here with onPlay is going to execute, just like in the event graph for an actor blueprint, for example. In order to use this wave player node, we need to connect it. So we're going to take onPlay and connect it to play. This is going to play whatever wave asset we specify. Now, we can hard code one in here, or we can hook one in through the input pin. And we have an input, which we have our default value set to, our first sound wave asset. So we can hook that in for the wave asset. Now, a wave player is going to play this wave asset, and we can have things trigger in response. Now, what we want to do is finish our sound wave by hooking something up to onFinished here. And our wave player has an onFinished node. So whenever our sound asset is done playing, onFinished will trigger, and then we'll officially be done playing this meta sound. But we also have an output down here that says out mono, and this is the resulting mono output. We need to specify what that is. That's going to be out mono from the wave player, so we can hook that up. Now we can test out our meta sound by pressing play. Let's check it out. Pretty cool, right? We also have a little bar to the right showing us the decibel levels of our sound. And we have some graphs giving us a visual representation of the sound wave. Pretty nice. Now, I mentioned there's a difference between mono and stereo. This is what mono sounds like, but I'd like to see what stereo sounds like, because our wave assets are indeed stereo sounds. They have left and right speaker information. So how do we harness that? Well, we can change our meta sound to a stereo sound by clicking on meta sound at the top. And in the details panel, we can change output format from mono to stereo. Now notice in the members panel, under outputs, we now have out left and out right. We have to specify the left and right outputs now, which means our wave player mono isn't going to cut it because we just have one out mono. Sure, we could pass the same thing into out left and out right, but that's going to result in playing the same sound on the left and right, which is really just what mono does. Since we want stereo, we're not going to use this wave player mono anymore. Let's delete that and right-click and type wave player and choose wave player 2.0 stereo. Now, this is very similar, except it has out left and out right. So we can hook those in right away. We can take out left, hook it into out left, take out right, hook it into out right, and onFinished can go straight to onFinished here. And of course, we need to take care of the inputs as well. OnPlay can go to play, and our rifle input can go to the wave asset. And now we can press play to see what stereo sounds like. There's quite a difference. It sounds much more immersive in 3D. So whenever possible, I like to use stereo sounds because they sound a lot better and more immersive. Okay, so now we have a meta sound, and we've seen some advantages to using a meta sound versus just playing a regular wave asset. For one, we can specify mono or stereo. But we can do lots of other things, and we're going to do a couple other fancy things in this video with our wave assets. For one, we're still just using a single input wave asset. And we have three, right? We're only using Rifle 01, but I'd like to somehow use all three. We can do that by selecting our rifle input in the members panel. And for its type, we can change the type to an array by checking isArray. And now its default value looks different, right? If we look at its node, the output pin, looks like an array, just like arrays in actor event graphs. Now, we need to set the values in the array now. By changing its type to array, it's now empty, and we can click plus to add elements to it and select the values for those elements with the dropdown. We can do it that way. We can also remove elements by clicking the little caret icon and clicking on delete. We can do that. And we can also shortcut this whole process by going to the content drawer and clicking on dock in layout. That's going to give me a freestanding window here. So I can find those sound assets here. I can click one, hold shift, click another, and get all three selected. And I can drag all three onto this array and release, and now all three are there. This is a handy shortcut to know how to do because, well, what if you have 50 sounds or 100? Not likely you'd have that many, but say 20 or 50, you can simply select all of them and drag them on, and then you don't have to click plus and select them from dropdowns. This is faster. Okay, I can close that content browser, and now we know that our input is initialized. So how do we use all three? Well, every time we play this sound, I only want to play one of them, but I want to play one at random. And there's a handy node for that. We can right-click and type random get. And there are various flavors of random get. Well, the type of data we're working with is wave assets. So we need wave asset array. Let's get that. And this node requires an in array. We're going to pass in our rifle input, which is an array. Now we do need to have our on play run through this node first before we get to the wave player. So we can break the pins and make sure that on play goes into the next input and on next goes into the play input to wave player. And now we're going to get one of the three sounds at random each time we play. And perhaps most importantly, our random get node has a return value, which is one of the wave assets in the array chosen at random. This needs to be hooked in to our wave player so our wave player knows what to play. So let's see how this sounds by playing it a few times. So as you can see, each time we're getting one of the three in the array played at random. And you can bias this towards one of those wave assets by passing in an array of weights if you'd like to do that. I leave that as an exercise for you to research on your own. But now we have a more sophisticated meta sound. Pretty cool, right? Now the last thing I'd like to do is randomize the pitch of our sounds just a bit. So I'm going to make some room here. I'd like you to notice that pitch shift is an input on the wave player. And if we put a number such as, oh, let's say 5 and press play, notice that our sound is played at a higher pitch. You can really bump it up, say 20, and that's way too high. But just to show you that this affects how the sound is played, we're affecting the pitch here. Well, each time we play this meta sound, we can give it a random pitch shift by creating a random float. We can do that by right-clicking and typing random float and getting a random float node. It has a next and an on next, so we need to run our wire through it. We can do that. I'll go ahead and break it. And from the random get, we'll hook on next to the next node on the random float and on next to the play node on the wave player. And just so we don't have wires going behind nodes, I'll go ahead and double click on this node and get a reroute node. This is really handy, allows us to reroute the wires around other nodes. You can always get one by double clicking on a wire. And for our random float, we get a value returned. That's going to go into the pitch shift. And we get a minimum and a maximum for the random float. So if I put a minimum of, say, -2 and a maximum of +2, then the random float will give us some random value between -2 and +2. And hooking that into the pitch shift is going to shift our pitch by that random value. So each time we play the sound, not only are we getting a random selection from our 3 wave assets, it's also going to have a random pitch shift to it. So we can play this a few times to see how that sounds. So it's a subtle change, but it gives us some nice variation. And the last thing we're going to do for our meta sound is adjust our start time. Because the sound has a bit of a build-up to it, as we can hear. And I'd like to push that start time to somewhere in the middle of the sound to give it a more rapid start. So I'm going to shift the start time by 0.08 seconds. It's not a lot, but we can hear the difference if we play it. I essentially cut off the beginning of the sound so that it sounds more immediate, less of a build-up. Okay, so now we have a meta sound, and we can actually play this instead of a wave asset. If we go back to BP Bot to our play sound at location and open the dropdown, because play sound at location is also capable of playing meta sounds. So we can change this to using our SFX Energy Rifle, and we can see what that sounds like. Let's go ahead and try it out. Excellent. That sounds amazing. Now, before we wrap up the video, let's take care of one little detail that we mentioned earlier, and that's that if I press play and move away from the drone, the sound still plays at the same volume as if I were right next to it. So we want an attenuation. We want a fall off. And our meta sound has to have an attenuation associated with it. Well, we can easily do that by clicking on the gear icon that says Source and scrolling down to Attenuation, where we have Attenuation Settings. And this property expects us to have an asset, but we don't have one in our project. But notice, as soon as we expand the dropdown, one of the options is to create a new asset called a sound attenuation. If we select that, it's going to ask us where we would like this sound attenuation asset. We're going to go into Assets, Sounds, Drone, and we can give this new asset a name. I'm going to call this ATT_drone for a drone attenuation asset. Let's click Save, and notice that it's automatically set here to ATT drone. And we can go back to the drone folder and open ATT drone, where we have a number of settings. The most important for now are the inner radius and the fall-off distance. The inner radius determines where the fall-off begins. It's set to 400. So if we're 400 units, which in Unreal Engine is centimeters, if we're within 400 units away, we hear the sound at full volume. If we're farther than 400 units, we start to get a fall-off. And the fall-off distance is that total distance. It's set to 3600. If we go beyond that, we won't hear the sound at all. So we can leave this attenuation at default settings, and we know that our SFX Energy Rifle is using it, so we can try to go far away from the drone and see if the sound plays at a lower volume. Let's try this out. All right, I didn't get that far away, so I'm going to change my BP bot. I'm going to go to the event graph and change the delay to 8 seconds. And that way I can get a little farther away before it plays the sound. So let's play test this. I'll get way over here. Okay, I didn't even hear it. I was clearly outside of the fall-off distance. I'm going to try again and not go so far away. Okay, so I heard it that time and it was quieter. So as we can see, our sound attenuation works. So in order for sounds to have a fall off, they need an attenuation, and attenuation settings can be adjusted in that attenuation asset. So now we have a sound effect, and we're playing that sound effect in our spawn blaster beam, and we're playing it at the location of the socket transform. So every time we spawn a blaster beam, we're now going to get that blasting sound, and that adds a whole new dimension of immersiveness to our game. So visual effects and sound effects are very important when it comes to making a game fun and immersive. Excellent job. I'll see you in the next video.